Welcome back to che531. In this video, I'll be talking about built-in functions in Matlab. There are several functions that we can use for nonlinear optimization. The first one, which we're going to go over in a minute, is for one-dimensional optimization, and that is called fmin_bound, or BND. So I think as this word stands for, this is for bound minimization. So that means we have to introduce a lower bound and upper bound to the variables, and we have to introduce the objective function. So the function takes 3 arguments, and then it outputs the solution, the optimal solution, and the function evaluated at the optimal solution. Okay. So this is primarily based on quadratic programming that we didn't actually cover in the class, but I leave that as a final project if any one of you is interested in working on that. So please, talk to me about it if you want to work on that. So the next function is for multi-dimensional optimization. And this is for linear programming. I think we talked about this before. It's linprog with the given arguments, so we're not going to go over that because in previous videos we talked about this already. We have 2 more Matlab functions for still unconstrained optimization. Unconstrained means there's no constraint. These can be used for nonlinear optimization in any dimension. The first function is fmin unconstrained, so UNC, and the second one is fmin search. And they're sort of similar, but there's a difference. And the difference is in fmin unconstrained optimization, we have to introduce the derivative of the function. So within this f, we also have to introduce the derivative. I'll talk about that in a minute. In fmin search, however, we don't need to introduce the derivative. So basically this is derivative free. Alright, so the first argument is going to be the function, the objective function, and in this case it's going to be objective function and the derivative. And the second argument is the initial guess. In all of these, actually, initial guess, I think I use x0, or if there are 2 initial guesses needed, then I use x1 and x2. Alright, and then on the output, we get the optimal solution and the function evaluated at the optimal solution. This is basically objective function at the optimal solution. Alright, now we step on to constraint optimization. So for constraint optimization, we have 2 functions to use. One is called fmin_bound. Well, this is actually trying to find the minimum of a function within some bound for x1 and for the independent variable x, let's say. If you have only one variable, then we have to introduce the lower bound x1 and the upper bound x2. And then Matlab is going to find this optimal solution between these 2 bounds. Okay, f is objective function, and the output is the same as before. This one, fmin_con, this is the most generic form of constraint nonlinear optimization in Matlab. It has all possible tuning knobs here. So the objective function, initial guess. If you have inequality, linear inequality, you put them in there. If we have linear equality, we have put them into these 2. So this is pretty much like a linear programming we saw before. This is the coefficient matrix, that's the right hand side. Now if you have a lower bound and upper bound, we also put them in here for the variables. So this thing is in addition to the linear programming function we saw before. Now we're going to have a nonlinear constraint. So this stands for nonlinear constraint. And in an example, we're going to look at that in a minute. And then the options. So options should include something like the methods, whether we want to plot the function or not, what kind of output we want to get, and stuff like that. So those options. And then output is as before. So optimal solution and objective function evaluated at the optimal solution. Okay. And then the last thing we're going to talk about is Matlab built-in function, which is used for semi-infinitely constrained optimization in almost any dimension. So in here, in addition to the objective function and initial guess, we also have to say how many constrained relations we have, and we have to introduce them into this semi-fcont function. So this is basically a handle. It's a handle to a function, and the number of them actually comes into this n theta. In any of these, if you have, any question and the notes and the examples that I post on Blackboard does not answer your question, the best is you go to Matlab help and search for these functions. There are tons of examples and documents on what each term is, how to use them, and I think with really self-explanatory examples. So take advantage of Matlab help, it's really useful. All right, so in the next few minutes, we're going to look at Matlab script, corresponding to these functions. So let me switch to Matlab. The first example we're going to look at is a sine function. It's a very simple example we're going to go over. So I'm going to minimize the sine function between 0 and 2 pi. So now you see I have some lower bound and upper bound. So I'm going to use fmin bound. In fmin bound, you need to give the lower bound, basically this is in a fixed interval. So this is the lower bound, that's the upper bound, x1 and x2 right here. And then in options, let's say I want to plot the function evaluated at every iteration. So I ask basically Matlab to plot the functions through Optim Set. So this Optim Set is a Matlab command where we say whether we want Matlab to plot the functions as iteration converges to the optimal solution. Okay, so whatever it's in Optim Set, always come in pair. It means you give the parameter and you give the value for that parameter. So I'm saying that, okay, I want to plot the functions, and what functions I want to plot? The optimal, the objective function at current optimal value. So that's the optimal plot f val, and that's basically how we have to write it. We lump them into options and pass the options through the argument list of fmin bound here. On the output side, we're going to get some outputs, the exit flag, whether it converges or not, the function evaluated optimal solution, and the optimal solution. And this is just to basically change the font size on the axes of the plot. So here is the execution. So the sine is minimized, and through 8 iterations, and you see this is the function value, and the value of the objective function is -1 at the optimal solution. Okay, so this is actually the result of having the plot function activated in Matlab. Now, if you want to know exactly at what x we get this optimal solution, then we have to look at the command window here. So the x value is at 4.7 radians, and the function evaluated that. So this should be around pi over, I think pi over, let's say 3 pi over 2. It should be 3 pi over 2, and you can actually check that. So 3 times pi over 2. That's the same number, 4.7. Okay, so that means the optimization went well. Alright, so that was the first example. The second example we're going to go over is Okay, now we're going to say what algorithm we want to use, and we're going to use a different function, fmin search. So fmin search, we have to say the derivative, right? Okay, so this is the function that I want to optimize. Okay, so actually there's 3 examples here. Let me just comment these out. Okay, so I'm saying the function we want to optimize is fun, but if you go down here, I introduce the fun function, which is this one, is x minus 1 squared and y minus 3 squared. Now I use x1 and x2 for x and y. And then here's the gradient of it. So I actually calculate the gradient, pass the gradient through the argument list. Well, through the output list, actually. Alright, so now my f actually has the gradient. And in the Optim options, I'm saying that I'm going to use fmin constraint optimization. I'm saying the algorithm is trust region. And I'm saying that I'm providing the gradient. So the gradient is true. And then we use this options as the argument into the fmin unconstrained. By the way, this is unconstrained optimization. So you see that I didn't introduce any lower bound or upper bound. Alright, there you go. So we can go ahead and run this code. And it spits out the solution. X1, y is 3, and the function minimized at 0. That means that's the minimum of the value, which I think is right, because so this is a positive term. This is also a positive term. The minimum of summation of 2 positive values should be 0. So I think this is right. And the solution should be at 1 here and 3 here. So that makes sense. Alright, so we're going to move on to example 3. In example 3 here, we have basically the same function. I create inline function, initial guess. So I like to see the iterations. So I say display iteration, and I want to plot the function. So this is fmin search, which does not need the gradient. So I'm going to run this code, and there you go. So this tells you the function initially start, well, this is the objective function start at 10, and the value goes down to almost 0. In something about 70 iterations, and at the end of the day you get the same solution, right? So this is f value is almost 0 in the optimal solution. So the solution converge, as you see here, it says that the solution satisfies the constraint, and this is the tolerance, the default tolerance the Matlab used for optimization. Alright, in the next example, which is I think the most, oh actually not that one yet. Okay. So in this example, now we're going to introduce lower bound, upper bound. So the first two are lower bound, upper bound for x1, lower bound, upper bound for x2. I don't have any linear inequality, I don't have linear equality, and I don't have any nonlinear constraint. So I just leave them empty. I say in the algorithm I'm going to use sequential quadratic programming. If any of you are interested in sequential quadratic programming for final projects, just come talk to me. This is in the note, but I didn't cover it because I left it as final project. I like to see the iterations. I say display iteration, and I'm using fmin con function. So you pass all of them into options, and then option shows up in the argument list. And from left to right, function, initial guess, inequality, linear inequalities, linear equalities, lower bound, upper bound, and the nonlinear constraint, which we don't have here. Right, we run it, you get the solution, fine, and the iterations and other information here. Okay, the last example we're going to look at is a complete, or the most generic form of nonlinear optimization. So, so the next part of this video I'll be talking about this example, particularly the most generic form of nonlinear optimization in Matlab. So stay tuned and thanks for watching.